Hi everyone, this is just a short video to show you how to plot QFL and QMFL FLT data on ternary diagrams. And just as a beginning reminder, ternary diagrams are these diagrams used for plotting three-component mixtures in which the percentage of A plus the percentage of B plus the percentage of C equals 100%, and those are plotted as percentages towards any one of the three A, B, or C poles. So here's a set of data, raw point count data. QM stands for monocrystalline quartz, QP polycrystalline quartz, CH is chert, P is plagioclase, K is K-spar, LV, LM, and LS are all lithic fragments of volcanic, metamorphic, or sedimentary origin. The other category is a place to put counts that do not fall under any of the other categories. These could be things like open space in the rock. They could be porosity, or cement, or matrix, or some other type of grain that is not one of our framework grains. And what we're really concerned with plotting is just this stuff. We are not concerned with plotting the other category. And so before we start, what we're going to want to do is we're going to want to subtract the other from the total so that we're reporting everything else as a percentage of all the framework grains and not including all these other things in there that don't go into our three-component mixture. So the total number of grains counted here, we're going to change to total framework grains, which would be 175. The total number of counted grains minus 25. Okay, so the first plot that we're going to make is the QFL plot. And Q is what we'll start with. Q is the total of these three things reported as a percentage of the total framework grains. And so if we add up those three components of Q, we get 100, and 100 divided by 175 times 100 will give us 57%. So that's our value for Q. Our value for F is going to be the sum of the two feldspar categories. Oops. And those two feldspar categories sum to 54 divided by 175 times 100 is going to give us 31%. And then our L is going to be the sum of all of these. Our L only is 21 over 175 times 100 is going to be equal to 12%. So to plot these values on the QFL diagram, all you do is you count from 0% Q to 100% Q. You find the value that you have, and 57% Q will lie somewhere right along this line. For our feldspar, we go from 0% feldspar, which would lie along that axis, to 100% feldspar, which would lie at that pole. We find 31%, which would be somewhere right along here. And then finally, we have 12% lithics, which will be somewhere between 0% lithics lying along this leg of the triangle and 100% at this pole. And lo and behold, because we've already got two values in here, the requirement that our three values here sum to be 100%, means that our point is already predetermined to lie along the 12% lithics line. Okay, we can do the same thing for QM, F, and LT, keeping in mind that QM is just this. F is still the same as it was before, and LT is going to be the sum of all of these. We still need to normalize everything to 175 counted grains, framework grains. And so let's do the same procedure. QM is going to be equal to 47 over 175 times 100%, which will be 27%. F will be the same as it was before, 54 over 175 times 100 is 31%. And then LT, which is already predetermined by our other two values, will be 74 over 175 times 100%, which is 42%. So to plot this, we just find the 27% Q line, the 31% F line, and hopefully those both lie along the 42% LT line, which they do, and our point plots there.